want to talk a little bit about what this tutorial is going to look like, what it's going to cover in total, and hopefully you'll find this helpful when thinking about applying to do game jam or even when you're making your own games or your own creations in general. So first of all, Unity is a 2D and 3D engine. You can kind of make any game idea that you have in mind inside of Unity. I like using Unity for its 2D skills. I prefer using Unreal for 3D, but Unity's 3D is very, very nice. It's very clean to use. It's very easy to use as well. So I highly recommend that if you're interested in doing a 3D or a 2D game, checking out Unity because first of all, it's free and it's pretty easy to use. Now, when you're creating games for Game Jam, um, typically what's going to end up happening is you're going to find a group to work with, and they're going to say what software they want to use. They probably will have some basic game idea, or they'll start pitching some game ideas, and you guys are going to have to try to figure out what it is that you want to create. And so understanding how to use Unity as a game engine is going to help that process a lot more because you'll be able to understand what you can actually accomplish in the short time that you're given. Um, and that's really, really important because one thing with game jams is you don't want to overscope yourself and bite off more than you can chew. So hopefully this tutorial will give you enough info on how to use Unity, so that at least if you aren't the person that's doing the coding, you're not the person that's doing the design, you're just maybe the artist or you're the sound guy. You have some experience with how Unity works and you can understand some of the problems that your team may encounter. So what we're going to be covering in this tutorial is we're just going to be creating a game from start to finish. Now we're not going to be focusing on the art assets that much because that's kind of its own area, creating art. So all this tutorial is going to cover is it's going to cover using placeholder assets. So kind of like what to do as a starting point for a game. It's going to cover basic collision. It's going to cover basic enemy AI. It's going to cover character movement. It's going to cover keeping track of score, and it's going to cover resetting the game in the case of your character getting destroyed or dying. And that's basically all this is going to cover. So it's for the time that we have, it doesn't sound like that's a lot. It doesn't sound like that's every component that goes into a full game. But it's enough of a starting point for everybody to kind of it's enough of a starting point for everybody to kind of see where their ideas can go from here. So understanding how to create a simple 2D platform like this with all those components in it is going to help you because once you understand how to do these simple things, you can kind of go out into the internet and find the more complicated stuff that you want to do, such as changing levels, making enemy AI that moves more than just what we have it move now, more complex code. So we're just going to be going over the basics today. So the first thing that I want to cover is I want to cover Unity's layout. So the layout of Unity is divided into 4 sections on the screen. We have the hierarchy, which is on the left-hand side. We have the viewport, which is in the center. We have the inspector, which is on the right-hand side. And we have the project window, which is on the bottom. The hierarchy on the left-hand side is more like is a list of everything that exists inside of your scene. So right now, all I have is a camera. So nothing really is in there right now except for that camera, but it's really going to be helpful later on when we have more and more objects. The center is known as the viewport. This is a window of what your project actually looks like, what your game is going to actually look like, kind of while we're working it. The inspector on the right-hand side is if we go ahead and select an object, it's going to pull up all the properties of that object, so we can change up things about the camera here, such as the position of where it's located in the world, such as maybe something like the size of it, how much it's actually kind of covering on our window, things like that. And then the project window down below is just kind of like a file directory of everything that we have stored inside of our game. So the first thing I want to cover is I want to cover bringing in files into your game. So if we are working with art, say for instance, and the artist kind of gives us some stuff to work with, we're gonna have whoops, wrong folder. We're gonna have a file window here, and we'll say oh, this is the art that was given to me. What we're looking for is we're looking for the PNGs. So I have some PNG files in here for the player, some ground PNGs, and a mass PNG, which is going to be my collectible, just because it's COVID time. We need some mass collectibles. People aren't wearing enough masks, so we're gonna add it in as a collectible. But how can I actually take these PNGs and add them into my project folder? Well, pretty simply, all you'll do is just select the PNGs that you actually want to bring into your game. So I'll select the mask and I'll select the player, and then you'll just drag them into the window down below, and then they'll be there in the game. So right now, all I have is just a little placeholder object for the player. It's just a little blue cube, and I've got a very simple mask PNG here that I drew. Didn't take long at all. And we're going to be utilizing these assets a little bit later. So importing files is just really simple. Any file that you want to import in, you just kind of find the folder that you're storing it in. You just kind of click on it and drag it into the bottom right here, and you'll be able to access it. Now you can take these assets and you can kind of drag them into your game, like anywhere that you want. And you can kind of just use them from there. And you'll notice when I drag them in, and they're going to appear in the hierarchy. Now, right now, the player is set to the same scale as my mask, and I can edit the size of that mask, and I will be doing so later once we actually start to set that up. So, the first thing that we're going to want to do too is we're going to want to learn how to use placeholder objects. So, let's assume for a second, let's go ahead and get rid of these. Let's assume for a second that I have no assets to work with, and I need to start developing some movement for a character. So one of the biggest stigmas in game design that I've noticed that happens in club, I've noticed it happens in actual projects. You know, it happens in some of my school projects. It's even happened in some of like the work that I've done outside of school. One of the biggest things that I've noticed is programmers and other people when they make a game, they always say, "I need art first," and that's not entirely true. You don't need to have some finished art assets to start working on some things. Now, for some things such as like character animations and like lining up animations, obviously you need the character completed and you need the animations completed. But when we're working for a game jam, we don't have time to wait for art. Okay? Most of the time, art's not going to be done until the last day. So you're not going to get art right away. So what we have to do is we have to learn to use something called placeholder objects. So in order to use a placeholder object, what we're going to go ahead and do is we're going to right click in the project window down here. We're going to come up to the create tab. And in the create tab, there's a huge list that pops up. The first thing that we're going to do is that we're actually going to create a folder. And we're actually going to call this folder assets. And inside of our assets folder that we just created, that's where we're actually going to go back to create. So I'm going to right click inside of here, go to create. And I'm going to go over to the sprites panel right here. Now on the sprites panel, there's a bunch of different sprites that we can utilize. There's square, triangle, diamond, hexagon, circle, and polygon. I'm going to go ahead and use square for right now. And what I'm going to use for this square is I'm going to call this square ground. So this square right here is actually just going to represent my ground. I just want to use this square as like a placeholder for my ground until my ground assets actually get created and I can utilize them then. So what we're going to do is we're going to go ahead and drag this square into our like window here. And what you can do is you can come up to this top of the top of the screen up here, and there's like 6 different options. There's a little hand right here, which kind of you can use to drag around the screen and kind of move it. There's a little arrow right here, which you'll notice some arrows are going to pop up around the cube. This is going to make it so I can move my cube wherever I want. There's a little like circular arrows. This is the rotation tool. It allows me to rotate my object. The next one is known as the scale tool. It allows me to increase the size of my object in a given direction. The next one is known as I believe this is the rectangle tool. Yeah, rectangle tool. This kind of allows you to use scale and like move at the same point in time. It's more just like adjusting the points on the rectangle and making it bigger. And the last one is it's the all tool, basically. Like it hits everything inside of one. So you can kind of just use like multiple options that way. It's just mostly rotate and move, if I remember correctly though. I don't know if it actually has scale in it. It might have scale. I don't remember how to do the scale though, but you can kind of just go over to the scale here and do it that way. So this is kind of how you can edit this object. Now every time that you kind of like rescale this, you'll notice that some of the properties are going to change. So if you wanted to, you can manually change this. So if I wanted it to be like 10 by 1, I can make it 10 by 1. I can change the position to be like hard set at 0, and then I can maybe make it like -2 in the y direction, so it moves down a little bit. So the big thing when we create ground is we want to make sure that the player can interact with the ground. And in order to do that, we need to add in something called a box collider. So I'm going to go ahead and search up collider. And we have a bunch of different collision options here. Now, colliders are boxes, or not boxes, but colliders are objects that allow for collision to occur. Now, what is collision? Collision is the act of one object kind of hitting against another and something occurring. In our case here, we want the objects to collide with one another, and we want the player to stay on top of the other object. We don't want the player to pass through it. So in order to make this like a whole solid object, in order to give it some mass or some in order for it to basically be able to interact with a player, we need to add a collider onto it. So what we're going to go ahead and do is we're going to go ahead and add a box collider onto this. So we're going to use box collider 2D. It's important you use 2D over just regular box collider because box collider just as is just set to default 3D. So we want box collider 2D. Now the box, you're going to notice that when I did that, a small little like green outline is going to appear around it, and I can even adjust something such as like the size to make this bigger than the actual box itself if I wanted to. You can also hit Control Z to go back at any point in time, just like Photoshop. Control Z undoes the last thing that you did. So if I make it like too big, I can just undo it. So this is going to impact the size of the collision box. Now the thing to note here is the collision box is going to go based off of this green line. It's not going to go based off of the object itself. So if you make the collision box smaller than the ground or bigger than the ground, the computer is going to see that green box as being the framework or what it interacts with, and it's going to hover above that. So by default, when you use these very, very simple like shapes, these placeholder objects, just adding a box collider or just adding in like a standard collider is usually just going to do the outline of the object by default. But when you're working on like complex objects that you create later, there's one that you'll probably want to use called a edge collider 2D or a polygon collider 2D, and that you can kind of like have a little bit more control over. So when you have to do like complex character collisions and stuff like that, you won't just be using standard box colliders and stuff. But for our purposes here, since the ground is pretty square, we're going to be using box colliders. Okay, great. So we have a box collider created here. Now, one thing is, if we keep adding in ground here and adding in like new ground, we have to add in a box collider every time. So we're going to look at doing something called creating a prefab. Now, creating a prefab is basically a prefabricated object. It's an object that we've edited beyond its initial state, and we basically turn it into a file down here that we can kind of just drag in, and it will be like a perfect copy of that. Now, the nice part about using a prefab is when you edit the prefab, it's going to edit all of the objects inside of your game. So what we're going to do in order to create a prefab is we're actually just going to take this ground up here in this hierarchy, we're going to hold down left click on it, and we're going to drag it down here into the project window. And notice how it's going to create something called ground, but it's going to look a lot different from my original ground. And the reason is if I go ahead and drag this in, I will actually be dragging in copies of this ground, and all of them will contain box colliders. So it's a very, very quick way to just create ground simply, and then you can like move it into your scene and like change up things. You can even change individual things. So if I want to make this one bigger or smaller, and I wanted to make this one bigger, I could, and that won't change anything. However, if we actually go in, and I'm just going to undo that real quick. If we double click on the prefab object, it's going to take us to a different window. And this is what the object, the prefab itself, looks like. Now, if we were to make this like a lot taller and thicker, if we actually go back into our original scene, it's going to change all of our objects that we've added in. So just take another look at that real quick. If I undo what I just did, maybe I can't. There we go. So if I go back here and I take a look at it, now it will be back to its normal size. And I kept hitting Control Z, which is why it moved everything. That's my bad. Whoops. There we go. I'll just drag in new ones. There we go. Okay. So if we adjust this inside of the prefab itself, it's going to change all copies of the other one. So say, for example, that I changed something like I added in a, I don't know. Let's just go ahead and add in like, we won't even add anything in. If I were to change something as simple as like just the size of it or where it's located or things like that, or I even change the collision box if I make the collision box bigger. If I take a look inside of my regular game, all of the collision box for these objects are also going to grow. So prefabs are really, really useful because you can kind of like create a nice copy of things that you're going to use over and over and over again. Especially when you want to like replace ground later, because if I wanted to just replace the ground sprite later, I can just go into the prefab and change the sprite renderer to a different like sprite. And we'll take a look at how we can do that later when we actually get to the character. The prefabs are very, very useful when you're using a lot of the same placeholder objects, such as ground. And even when you're doing things such as like enemies too, it's very, very useful to have a prefab that you can just edit. So creating prefabs is just a quick way that you can kind of like create things very, very quickly, such as platforms, environment, things of that. Okay, so next up what we're going to be talking about is we're going to be talking about how to create a character. So now that we have some ground for our character to actually walk on, and we've given that ground box colliders that the player can interact with them, we're going to be creating our player character. Now, in order to create the player character, we could add in another ground or another square asset here, but since I already have the player asset, kind of like a placeholder asset for the player made, we're going to be using this little blue box right here. So you could just kind of right click, create, you know, sprite, and then go to square here and use that for the placeholder. But I'm going to be doing just some like fun stuff with this kind of to show you that you can create like, you know, very simple characters this way. Now, we could just drag this in here and start creating our player based off of that, but we're not actually going to go ahead and do that. We're going to go ahead and go to create, instead of the hierarchy, we're going to create something called an empty. Now, an empty game object is a game object that does not have anything inside of it. It doesn't have any data. So if we take a look at the game object inside of our inspector, there's nothing inside of here. Now, this is very, very good for our player game object because we want something that holds all of the information of our player. It's kind of like it's going to contain everything. It's kind of like a folder almost for it. So we're going to go ahead and name this game object player. Whoops. I'll go ahead and delete that. Name player. And what we're going to go ahead and do is we're going to go ahead and add in our player. So we're going to drag our sprite. So we're going to go ahead and click on this blue box and drag it into our empty game object up here. And you're going to notice it's going to appear right underneath of the player game object up here. Just to differentiate between this, I'm going to call this one player sprite, just so there's no confusion. Great. So this is our player sprite. This is the box itself, and this is our player object. Now we want this box to line up with the arrows that we have right here. So inside of our player sprite, we're just going to go ahead and set X, Y, and Z to 0, 0, 0. And this will make it so that it is perfectly lined up with our player object, is perfectly centered right now. So something to note, when you kind of drag it in for the first time, it will not be set to 0, 0, 0. So just make sure that you set all these to 0, 0, 0, just so we have no confusion later on. So we'll go ahead and actually just set this to 0 over here as well. We'll put it 2 above, and we'll go ahead and set this to 0. So I've dragged in this player sprite and this player object, and if we actually just go ahead and hit play on the game, what's going to end up happening is, well, nothing is going to happen. And the reason that nothing is going to happen is because, well, simply enough, it's because we don't actually have anything occurring right now. All we have is the objects added in. We don't have any physics or anything like that. The first thing that we want to do is we want to give our player some physics. So inside of our player game object, not player sprite, player game object, we're going to go ahead and add in a component. We're going to look for something called a rigid body 2D. Now, rigid body 2D is going to basically apply physics onto our character right here. So we can go ahead and hit play now, and what's going to happen is when we hit play now, the block is actually just going to start to fall. Now it's going to fall right through our ground right here, and the reason it's going to fall right through our ground right here is just simply because we don't actually have any collision going on right now. There's a collider inside of our ground, but there's no collider inside of our player object to track that. So inside of our player sprite, or we can do this inside of our player object. We'll actually do this inside of our player object. We're going to go ahead and hit add component, and we're going to go ahead and add in something called an edge collider 2D. Now, an edge collider 2D is a little bit weird because the way that an edge collider 2D works is it makes this little green line right here. And we actually have to manually offset this green line to line up with the edges. Now, the reason that I use an edge collider 2D here instead of just using a regular box collider is because box colliders, when they drag against each other, can sometimes get stuck. So by using an edge collider right here, this is kind of like a way that I can have a little bit more control over where my points are actually going to line up to. And I just want to show off using other colliders too. So by this one, you can actually select the points and how many points there are. So if I want to add in a third point, I can add in a third point. And then you can kind of adjust like the size of where those points actually are to kind of like make a little makeshift box. And we'll actually be adding in about 5 points, I believe, to make this work. But we're just going to add in one at a time just so we can see the new point, kind of like maneuver that new point around. And I'm just roughly getting it into place. I'm not worrying about like the specifics of it right now because I'm just going to manually go over all this once it's pretty relatively close. Yep, and then we'll do a 5th point. And the 5th point is going to equal exactly the same as our other ones. This is actually just going to be 0. Great. So I got this like really weird makeshift box right here, and all I'm going to make sure is that these numbers just kind of line up with what they should be. So I'm going to make this 0.67. I'm going to make this one 0.67. Just so it's all kind of straight and lined up. I'm going to make this one also 0.67. So that's lined up too. And then for these ones right here, I'm just going to make them 0.3 and 0.3. Great. So I've got this kind of like makeshift box right here, and it's a little bit bigger than I kind of intended it to be, which is totally fine. I can always, adjust the size by just kind of like moving this down a bit. Maybe I'll do 0 instead. So just 0.6 instead of 0.63. Oops, there we go. And again, you do not have to do this way at all. You could use a box collider, but you will notice that a box collider, when you're colliding with other box colliders, will tend to get stuck. So I use the edge colliders as a way to avoid that. And I'm just kind of adjusting, and that's pretty close. It's pretty good. But once we add in that edge collider inside there, once we add in a collider of any type, once we hit play now, it should collide with the other object. Yep. And so now it'll kind of be like above that. And again, you do not have to use an edge collider. That's just a little bit. I'm just kind of troubleshooting a future problem that you'll have. You can just use a box collider 2D. I can disable the edge collider real quick, so I'll just get rid of this edge collider right here. Wherever one, yep, this one right here. So you can get rid of it by just going here, and then I believe remove component. Yep. So if I just go ahead and like disable this edge collider and use this box collider instead, and I hit play, it'll work totally fine, as it should. But again, I've had some problems with it, so I'm using the edge collider this time around. So now that we have this edge collider and this rigid 2D body, why don't we get some logic going on? Let's talk about some scripting work. But before we actually get into that, what I want to do is kind of show you something fun that you could do to kind of give your player like a little bit more life to it. You can add in as many sprites as you want into your player. So if I wanted to, for instance, let's say I add in, we'll create a sprite and we'll create just a little circle. And let's say I just use this circle. What I could do is I can actually drag this into my player object and readjust this circle, and I can even bring it to the front a little bit too, so it's above. It has like priority default. We'll add in a sorting layer. Now we'll get into that in a second. But what I could do is I can kind of drag this like into position to kind of be like an eyeball. And one thing that you can do is there's these things called sorting layers here, or even layers up here. And what you can do is you can actually give your player sprite a unique sorting layer. So what I can do is I can add in sorting layers, and I can hit this plus button here to add in 2 sorting layers. And I can call this player base, and I can call this player details. And what will happen is when I assign this the sorting layer of player base and this the sorting layer of player details, the player details will kind of come in front. And then what I can do is I can kind of like resize this circle right here to kind of be like little small like eyeballs for my character. And I can kind of like have like a little bit more like character customization this way. So I can kind of like drag this eye into position here, Control C, Control V it, and all of a sudden I have this little character that has some eyes now, and when he moves, it moves all together. So it's kind of like a way that you can like not really have to do much work and have like a very quick placeholder character. Again, just to clarify that, because I know I went through that pretty quickly, there's this sorting layers things here instead of all of these sprite renderers, and by adding in sorting layers, the ones at the top are going to be the ones in the back, and the ones at the bottom are going to be the newer ones. So I had player base kind of be like the background for the player, and player details be stuff like the eyes. And if I even wanted to add in something like a little square too, maybe I'll just add in the ground square into my player. I could already go ahead and give that the details sorting layer, and I can kind of drag this into position on my character. Maybe I could like resize this a little bit, kind of give it some more detail that way. And then all of a sudden my character has a tiny little mouth that they can utilize too. But I'm not really a fan of the mouth. I thought the eyes are just kind of cute, but I'll give them like a little like unamused face. Oh, I do not want to drag the player sprite though. You could also kind of drag this into the player sprite object as well, just kind of for more organization, but I kind of just do it this way. It works pretty well. Alright, so we'll be getting into the coding now. Okay, so I have this little character made here, and there's actually a few more things that I actually want to go ahead and do. The first thing that I'm going to go ahead and do is I'm going to set up this character to have 2 more things besides what we just kind of created. And to have some more organization into our player character, what I'm going to go ahead and do is I'm going to go ahead and drag these details inside of the player sprite like I talked about doing earlier, just to kind of just keep this organized, because we're about to add 2 more things into our player. So inside of our player, the next thing that we're going to add is we're going to drag the main camera that we're working with, and we're actually going to put that inside the player. Now what this will allow us to do is this is going to allow us to kind of like move the main camera around with our player. So as our player moves, the main camera is going to move. And what I'm going to do in order to keep the main camera centered on my character is I'm just going to drag the main camera up to be on top of my character. So that way when my character falls, it kind of stays pretty centered. Oops, I did not put that inside of my player. My bad. There we go. So now that it's inside of there, if I go ahead and give it a play, the camera's going to actually move with the character. Whoa, and we got some like really crazy physics stuff going on, which we'll fix in a little bit. So we've got all of this pretty much figured out. Oh, I also put ground accidentally inside my character. Whoops, no wonder it was being weird. There we go. If I hit play now. Great. Okay. So weird game design glitches that you can have. Love it. So now that we've got our main camera inside of our player that's going to follow our character around when the game plays. Next, what we're gonna have to do is we're gonna have to add something, an empty object, into here. So we're just gonna go ahead and create an empty object, and we're gonna actually make this. We're gonna call this ground check. And we're actually going to drag this empty object down below our character just slightly. Now, it's impossible to see an empty object because there's nothing inside of here, and there's a little square right up here that has these icons on it. We're going to go ahead and give it a red icon, and you're going to notice it's going to say the word ground check underneath of it. Now, this is basically, we put this on the bottom of our collider in order to check when the player actually is touching the ground. This is essential for jumping because we basically are going to use this ground check to make sure that the player is on the ground so they are able to jump. And it's also a good way to track if the player is actually on an object that they can move on that will be ground. And we'll be going over that in a little bit. But all you need to do is just right click on player, create an empty object, go ahead and go up to the square up here, give it the little red icon, call it ground check, and you're good to go. That's about all you need to do for that. And that will not appear in your game either when you play it. That red icon will not appear. It won't say ground check underneath your player, but it will say that inside of your scene view. So this is kind of like behind the scenes of what you can see as a developer versus what the player is actually going to see. Okay, great. So now that we have all that set up, we're actually ready to add in our script. And we're going to go ahead and click on the player. We're going to hit add component, and we're going to add a new script. And we're going to go ahead, whoops, I clicked it too fast. We're going to go ahead and give this script a name. So we're going to do new script, and we're going to call this character controller. Now, I can't go into full detail about all the scripting, and I kind of have to go through it quickly just because we have to get through this as quickly as possible. But I will be talking about a little bit of C# coding and stuff like that. At least enough so that people new to coding can understand what we're doing as we code. So when you create a script, the script is going to be available in 2 places. It's going to be available inside of where you placed it, inside this add component, so it'll be inside of the player object, the main one. And also it's going to be available inside of your project window down here. We're going to go ahead and double click on the character script inside of our project window, and that's going to open up Visual Studios for us. Now Visual Studio comes equipped with your, Unity, so you do not really have to worry about downloading Visual Studio because it will download automatically with Unity. Great. So now that we are inside of the code here, we're going to go ahead and do a few things. So again, I can't talk about all this stuff here. This kind of goes into classes and things like that, but I will talk about what I'm doing, what the purpose of it is. And I'm just going to try to get through this as quickly as possible and be as descriptive as possible. So between these parentheses, these curly brackets, we are going to go ahead and start to type in our variables. So in C# and in C++, when you're working in classes, you can declare variables basically anywhere inside of these 2 main curly brackets, and typically it's done before the functions are created. So we're going to go ahead and create some variables at the top here. So we're going to add in more variables as we go, but the first ones we're going to be creating is we're going to be creating something called a public float. Now a float is basically a number value that has a decimal point, is kind of the shorthand. So anything like 3.02, anything with a decimal point really. But what we're going to do is we're going to go ahead and give it the name of speed. Now, and then we're going to end it with a semicolon. Now, you're probably wondering, why didn't I assign a value to speed here? Well, the reason I didn't assign a value to speed here is because I used the word public. Now, the word public and private are really, really interesting inside of C# coding, inside of Unity. When you use the word public before a variable or before a function or anything, you are actually allowed to edit that variable inside of Unity. Now, what do I mean by that? Well, if I go ahead and attach this to Unity, I go ahead and save it to Unity by hitting attach to Unity at the top here, and then I hit the stop button because it's already attached. If I go back into Unity and I click on my player object, you will notice that underneath the script, there's going to be a variable here called speed now, and I can set that at any point in time. So by using the word public, I basically have control over what I want this variable to be whenever I want it to be. And this is really important for things such as speed, and things that we want subject to change, such as like how high the player can jump, how fast they can move, things like that. We can actually edit that within Unity without having to come back into the code. So you're going to be seeing me use this word public and the word private a lot. Private's kind of the same ordeal, Private just kind of has to deal with more of... Private is more like you want it to be edited in the code versus you want it to be editable in Unity. You could just use the word float speed, that works too, but public and private are kind of great ways to subcategorize them. So we're going to use public float speed. We're going to use another public float, and we're going to give that variable name a jump force. So it's going to be jump force. So that's how high the player is going to jump. We're going to be doing a private now, and we're going to be doing a float, and we're going to call this move input. And this is going to have to deal with how the player is going to be moving. We're basically going to be getting if they're moving left or right, and we're going to be storing it inside of move input to use later on. We're going to be using a private, and this one's going to be different. This is going to be called rigid body 2D. So that rigid body that we added into the character inside of right here, we're actually going to be calling upon this in code, and we're going to be giving it the shorthand RB instead of having to write out rigid body. So the variable name is going to be RB, and it's going to be referencing that rigid body. It's going to be how we're going to be moving. And then we need 5 more variables before we actually get started encoding. Next, we're going to be using a private boolean, and we're going to be calling this is grounded. So this is checking if the player is actually on the ground. Booleans store true or false values. So if they're on the ground, it will be equal to true. If they're not on the ground, it'll be equal to false. We're going to be adding in a public transform called ground check, and this is using that ground check object that we created earlier to check if the player is on the ground. Transform just kind of has to do with the position it is in space, or in our case, below the character. Then we're going to be doing a public float, check radius, and this is basically defining a radius of like when we want things to actually occur. So when so if we want to check if there's like ground nearby or things like that, and we'll go into this later. We're just adding this in first, and then we'll come back to it. We're going to be adding in something called a layer mask, which we haven't actually talked about masking and layers yet. So we're going to be doing a public layer mask of what is ground. And then last but not least, we're going to actually get the game object that we're working in, which is the player itself. So a lot of stuff there. And we just kind of declared variables. Now, again, variables are just kind of placeholders and values that we use later on, and we can kind of have as many variables as we like, but these are all going to be basic variables that we're going to be using to code in movement. Now, again, just because we're kind of crunched on time, normally I wouldn't be creating all of these variables at once. I'd be creating them like as we go. But I wanted to create them all first up here to kind of give you guys time to look at these variables, copy them down if you want to copy them down if you're following along. Just in case, just so we can kind of like move through this code as smoothly as possible. And we'll be coming back and talking about these variables too. So inside of our void start, the first thing that we want to do is we actually want to use this rigid body. And we want to get our rigid body first because all of our physics-based simulations, all of our movement has to relate to that rigid body. Without that rigid body, the object would just be stuck in space. It wouldn't be able to move. So the rigid body we need to actually acquire. So right now we don't actually have anything set for the rigid body. And the reason we set it to private is because we're going to call upon it now. So we're going to be doing RB, which is the shorthand for our rigid body. We're going to be doing is equal to get component. Now get component is an already made function that exists in Unity, and we're going to get the component called a rigid body 2D. And then we're just going to do parentheses and then semicolon at the end. So what this is going to do is this is basically going to have the computer access this rigid body right here, and we're going to be editing it later. And we're going to be changing things such as like the mass, well, not the mass, but mostly just like how it's moving. And that's going to have to go into like info and the constraints and stuff. So we're just essentially getting the component here so we can edit it later on. Now, all of our work is basically going to be going into this update here. So update's really, really cool because what update does is update kind of like is going to run it as the game goes. However, we're also going to add in a second one. Instead of using void update for everything, we're going to add in a second one called void fixed update. And private void fixed update is one that already kind of exists. It's just isn't added in by default. The difference between fixed update and update just essentially kind of has to do with when things are being updated. So update runs every single frame. Fixed update runs in between specific intervals. What we're going to be using our fixed update for is we're going to be calculating what direction the player is facing when they are moving and things like that, and it's going to be basically calculated a little bit cleaner than update. inside of update, we're going to be doing stuff for our ground, or I'm sorry, for our jump. But inside of fixed update, we're just going to be moving this. Now you could put all of this inside of update, and it will work totally fine. I've just found it works a little bit cleaner when you use fixed update for handling movement. But again, it's really a preference thing. So the first thing that we want to do in order to make our players move is we want to actually check to make sure that the player is grounded and is on the ground when they move. Now they can move up in the air. We just want to check to see if they're grounded because that's going to determine if they're able to jump or not. And we need to make sure that when our player is moving and changing their position in space, we are constantly checking if they're grounded or not. So we're going to first check if they're grounded. So we're going to do is grounded is equal to, and we're going to be using physics 2D. And what we're going to be doing is we're going to be using something called an overlap circle. Now, an overlap circle basically draws like a circle around the character, and it's going to check if something is inside of that circle. So all of those things that I made earlier up above here, we're going to be using some of these variables. So the first thing we're going to be using is we're going to be using our ground check dot position. So this is going to take the position of our ground check as the first kind of condition it's going to look at. So it first looks for a point in space. So the point in space is going to be the ground check. Okay. Then it's going to compare that with the check radius. So it's going to use the check radius to kind of like see if anything is if any ground is inside of that check radius. And this circle is really just going to be really tiny. It's going to be like the size of this ground check. So it's basically making sure this ground check is colliding with the ground. And then last but not least, we have to add in one more called layer mask, and that's what is ground. Now we haven't actually defined what layer masking is yet, but what this has to do is with what layer and what tag it has. So in order to check to make sure something is ground, we need to actually go into our ground prefab. So we're going to go ahead and go into our ground. Oops, I'm sorry, that's not the prefab. This is the prefab. And we actually need to give it a layer, and we need to give it a tag. Now for the layer, what we're going to do is we're going to add in a layer, and we're going to make this layer right here called ground. And the reason that we're going to go ahead and do this is we're doing this just to kind of make like a ground layer to make sure that that's what's being checked. And remember, since we're doing this inside the prefab, once we add this into our ground right here, so if we were to change this layer to ground and we go back, all of our ground that we have inside this prefab is going to have that applied. So notice that this ground over here now has a ground layer up here, and that's exactly what we wanted. We wanted that to happen just so that way we don't have to kind of go back and like change all of our ground. We're going to go back into the prefab real quick, and we're actually going to give it a tag too, and we're going to assign the tag to be called ground as well. This is like another layer of sorting things. You basically just using the layer is good enough, but giving it the tag ground in case you want to use tags versus layers. Layers have to do with how things are sorted. Obviously, like layers that have higher numbers are going to be in the front, versus layers that have lower numbers are going to be more geared towards the back. It's kind of like the sorting layers that we used earlier down here, but it's just kind of like more organized inside of Unity. Tags have to do with which we'll be using tags when we get into enemies a little bit, but tags have to do with how things are categorized, and by giving this a ground tag and a ground sorting layer, it's kind of makes it very, very easy for us to interact with. So let's get back into our code though, because we kind of went off on a tangent there, just to kind of explain why we're doing that. Great, so this is basically going to check if something is grounded or not. Now we could actually check to make sure if it's grounded or not by inside of our void update running something called not cout, it's debug.log, and we can actually do is grounded inside of here. And what this will do is this debug.log, if I attach this to Unity as is, I might get some errors with my player because I have to like actually like assign some stuff. But if I were to like say what is ground and I were to apply that to the layer of ground, and I were to drag my ground check into here, and I'll drag my player into here. And again, we'll go over this in a minute, but if I were to test this out as is, when this hits the ground, it should say true when it actually touches the ground. So notice if I were to drag my character higher up into the air and throw him up here, and if I were to play the game, it's going to output false, 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 false because it hasn't hit the ground yet. But as soon as it hits the ground, it's going to change over to true, which basically means that now the player is grounded. They are against the ground, which is super, super useful for jumping. Now over here is kind of like what I talked about earlier, which is these like public and private stuff. And I basically added drag in objects for the game to check that. So for the player object, I dragged in the player object from the hierarchy over to here because that's going to be the player object. Again, the computer doesn't know what the player object is because I assigned it this public variable. Public variable means that it's subject to change inside of Unity. So instead of hard coding it in case like I change my player object, I can assign my player object at any point in time. I can even assign the ground to be my player. If this ground thing was my player, I could make it my player. Or I can make it the player here, which obviously is the player, but it's basically subject to change. And by having it subject to change, you have a greater range of control over things. So we'll go over this again later on once our character's like more ready to move and stuff like that. I just wanted to show off like what that code essentially does and why it's important. So we'll get rid of that debug log, and we have that is grounded to actually check to make sure that it is on the ground. What are we doing? Great. Okay. So now that we know that it is grounded, what is next? Well, what's next is what we have to do now is we have to make sure that the character is moving. So we're going to be using the move input. So the move input is actually going to check if an input occurs on the horizontal axis. So the horizontal axis is basically left and right. Hold on one sec. There we go. Horizontal. There we go. Had to make sure I could spell horizontal right. Alright, so the horizontal axis is essentially left to right. So by default, inside of Unity, WASD moves the character and so do the arrow keys. And the horizontal axis is basically A and D and the left and right arrow key. So we don't actually have to code in if the key is pressed down. We can actually just check if the axis changes at all, or if any of those inputs are pressed by using input.getAxis. So it also works too for controller compatibility as well, so it's a little bit nicer than like hard coding in if a button is pressed down. But for jumping, we're going to be hard coding in if a button is pressed down. So that checks if there's any change on the axis, if that means if the player puts in a left or right movement. Now what we're going to do is we're going to be using rb.velocity. And this is actually going to make our character move. So by using this velocity value, remember RB is the rigid body. So by applying velocity onto it, it's actually going to move our character to the left and right based off of what that input is. Now, the way that we're going to do this first is we have to calculate movement. So in order to calculate movement, we're going to create something called a new vector 2. And essentially a vector 2 is just a fancy way of saying, hey, I want you to adjust this transform value in the x and the z, or I'm sorry, the x and the y position. And that's essentially all a vector 2 is. A vector 2 is just x and y. A vector 3 would be 3, that's x, y, and z, but a vector 2 is just x and y. So we're going to be using a new vector 2, and the way we're going to calculate this vector 2 is we're going to calculate this vector 2 by using the move input, so what direction the character is being moved in, left or right. We're going to multiply that by our speed value, so that's going to be our x value. Our x value is going to be that move input, where it's moving, if it's moving left or if it's moving right. It's going to give us a value, and it's going to multiply that by speed, and it's going to move it in that direction. And then for our y value, all we're going to be using is we're going to be using rb.velocity.y. And essentially, this is just maintaining the velocity. Whoops. Velocity. I think I spelled that wrong. I think I butchered that really badly. No, it's actually correct. I don't know why it's underlined in red. Oh, I did vec velocity. So all this is basically doing is it's maintaining the same y value. It's just using rb.velocity.y. So it should just by default be set to 0. It might change a little bit, but for the most part, when it has physics applied to it, it will not really change anything. You could put 0 in here, but using rb.velocity.y just kind of makes it so that the player doesn't just hover on the same plane. By using rb.velocity.y, if you have any slopes or any inclines, the player will just automatically go up them, and it will kind of keep the calculations the same. So you could put 0 in there if you have no slopes in your game, but it's safer to use rb.velocity.y and just use the velocity y value. Just because that way if you have slopes or any inclines whatsoever, you're not like glitching through the floor or having like physics Okay, so next what we're going to go ahead and do is we're going to go ahead and make sure that our character is facing either left or right, and that's going to determine which way they're facing, and it's also going to determine which way they're moving. So we've already determined which way they're moving based off this move input axis, and we're actually going to be basically using that in order to kind of like move our character. So by default, our character spawns in facing the right direction, okay? They spawn in by default facing right. So what we're going to go ahead and do is we're going to go ahead and create one more variable up top here. And we're going to call this one a private boolean, and we'll call this facing right. And this is going to be equal to true at the beginning. Now, if your character is facing left at the beginning, you can just have this equal to false. But since my character is facing to the right, I have his little eyes, pointing in the direction to the right here in his weird little facial expression. Since it's pointing to the right, what we're going to go ahead and do is we're going to go ahead and declare this as facing right. So, since this boolean is facing right, we're going to come back down here to private void. And what we're going to check is we're going to check if the character is facing right. So if facing right is equivalent to false, and the move input is less than 0. So if the character is moving to the left, notice how the x value is going to start to decrease, okay? So when you move the character to the left, the x value is going to start to go down. So if the player is not facing to the right, okay, if they're facing to the left in this case, and the move input is decreasing, okay? So if they're not facing right and the move input is decreasing, they are facing left, which means that we have to change how the player is rotated. And in order to do that, we actually have to add in a custom function. So the function we're going to add is we're going to add it below update, but in between the parenthesis or the curly bracket for this class here, we're going to create something called void flip. Now, void flip, all it's going to do is it's going to flip the game object accordingly. And we're going to be putting in a game object here called x. Now, the game object actually is going to be our player that we're going to flip. But we don't have to declare that here because this flip function can actually work for any object that we want, but it's really only going to work for our character. But we're going to make it work for any object that we want, so we can just repurpose this code later on. So inside of here, we're going to check, first of all, if facing right is equal to not right. Basically, if it's facing left, something is going to happen here. So the first thing we want to check is to make sure that it's not facing right, okay? If it's not facing right, what we're going to do is we're going to use something called a vector3 scalar. And all this is going to do is it's going to transform local scale. All this is basically going to do is we are going to multiply the vector3 scalar, or the scale of our object, by -1. So basically all it's going to do is it's going to take this value, the scalar value here, it's going to take its x value, and it's going to multiply it by a value of -1, which is just going to cause it to flip. So in the case that this is called upon and it is not facing right, it's going to multiply the scalar by -1. Now, if it is facing to the left, okay, if it is the opposite, it's going to multiply that by -1, causing it to flip to the right. Now, what do I mean by this? So visually representing this, and I'm just going to finish this off by doing transform.local scale to equal scalar. This is a little bit confusing to understand. Whoops. So all this is going to do, this code right here, is the first thing it's going to do is it's going to set facing right equal to the opposite of what it is currently at. So when we call upon this flip function, we call upon this function with the idea that it's going to flip. The only time this is going to be called upon is when we want the character to flip. So it's only going to flip when we call upon this flip function, okay? And we're going to be doing this right here. It's going to first set the facing right value to the opposite of what it's currently at. So if it's true, it's going to be false. If it's false, it's going to be true. Next, what we're going to do is we're going to take the scalar value, okay? Or in our case here, our scale value right here called scalar, our x value, okay? And it's going to get its current value. So right now its current value is set to 1. Then it's going to get the current value of all these scales here, and we're going to zero in on the x, and it's going to multiply what it is currently by -1. So -1 times 1 is just -1, which is going to cause it to flip. And then it's basically just going to reset all of these to just be like -1, 1, 1. It's just a fancy way of saying like, hey, set all this equal to what it is currently at now. So if we flip it, it's going to change this to -1. Now, let's say, for instance, the player starts to move to the right. Then what it's going to do is it's going to run all this code again. So facing right, so it's right now it's facing left, so it's going to set this equal to right. It's going to multiply this by -1 again, which -1 times -1 is just 1. It's going to set it back to 1, and that's going to set this all here. So the code looks confusing, but that's essentially all it's doing, is it's just changing that scale value right there. So looks a little bit confusing, but all it does is just multiplies it by -1 according to how we want it to be. And then literally all we do here is, in order to flip the player, we just type the word flip, as we did down below. Inside of parentheses, we put what object we want to flip, and that will be our player object. Great. And then if it's facing the left, so if it's doing the opposite, what we'll do is we'll just do else if, and if facing right is equal to true, and move input is greater than 0, then what we are going to do is we are just going to flip the player. So believe it or not, that's actually all the code we need in order to make this work. So if I were to attach this to Unity and run this code as is, what's going to happen is this player is going to be able to touch the ground, and he's going to be able to move side to side, but he doesn't have any velocity applied to him yet to actually like move him across the ground. So we can kind of get this like really funny like looking back and forth kind of thing going on here. And again, make sure that you go into your player object and you're dragging the appropriate things here. The other thing, the reason it's not moving either is we don't actually have any speed applied to it. I just realized that. So we can actually go ahead and change that now. So again, when you click on the player object inside the script, you have to make sure that you set the player equal to player by dragging this in here, or you can hit this little circle and finding the player object inside the list. Make sure that you set the ground check equal to ground check. Make sure that you set the what is ground equal to the ground layer up here. So instead of changing the player to the ground layer, just make what is ground equal to ground. Give it some speed. We'll give it 5 speed right now. We don't have to apply jump force yet because we haven't actually made jump force. And if you want the radius to be greater, you can do it 0.1. This is just the check radius for the ground check. This is when they're actually hitting the ground. I usually do 0.1 here, just because I don't want it to be pure 0. But you could make it be pure 0. So now when we hit, we'll be able to actually move, and we have some movement here. So he's kind of like rotating a bit, and the reason he's kind of doing that when he's like almost like hanging off the platform is just because of how physics works. One way that we can fix this is we can go into the rigid body inside of the constraints, and we can freeze the rotation of the z-axis, as well as actually just freeze the rotation. Should fix that problem if I remember correctly, and we'll go test that out right now. Yep. So I'm no longer like wobbling about anymore. So yeah, that is how you can do a quick little like movement movement with your character. Now we still haven't done jump yet, and we're gonna do jump really quickly. Remember that these values, I'm gonna move this down closer. These values are subject to change. So if you want the speed to be 20, you can have the speed be 20 at any point in time, and the character will move significantly faster. So you can change this at any point in time, and this is just very, very basic movement. And you can do stuff like hold against the wall here, which that's just kind of like one of the things that you kind of have to like work with. You can change that a little bit later on too, to kind of like put slopes here to make them fall off. But for right now, this kind of suits our purposes. Cool. So next up, what we're going to go ahead and do is we're going to go ahead and add in jumping into our character. So inside of void update is where jumping is going to take place. And all we're going to do for this is we're going to check if they're grounded first. So the first thing that we're going to do is if they're grounded. So if is grounded, so if they are on the ground, if that's equal to true, then what we're going to go ahead and do is we're going to go ahead and check a few things. First thing that we're going to check is we're going to check to make sure that the player wants to actually jump by checking if they've inputted the jump. So we're going to do get key down. And we're going to check to make sure that the key pressed was the key code of space. If the key code of space is pressed, meaning if the player wants to jump, we just apply velocity to the character in an upward direction. And we can use this thing called vector2.up. This is basically an already coded in, I keep spelling it veclocity. This is basically an already coded in vector that's going to move the character in the up direction. So it's basically just going to move them in the y direction upward, and we're going to multiply that by the jump force, and that's how far they're going to move up. And that's literally all you need to do for jumping, is just check to make sure if they're on the ground, check to make sure if the key that you wanted that was pressed, and then just multiply it by something in order to make it move up. We'll go ahead and attach that to Unity and go ahead and give that a play. Before we do that though, we're going to make sure that we actually apply some jump force. We'll give it a jump force of 10. And so when my player hits the ground, if I press spacebar, they'll jump. Now I can keep spamming it, and you'll probably hear this in the background, and it will not jump anymore. It'll only jump when they actually hit the ground again. So you could do a double jump by adding in like a little int counter inside of there. He keeps getting stuck on the side there. Oh no. I don't like that he gets stuck there, but it's fine. My jump's not good enough. But that's probably actually has to do with the edge colliders. I'm sure if I did a box collider instead on the character, so if I got rid of the edge collider and did something like a box collider, which we'll just add one real quick. We'll see if that works. Boop. No, it still does that. That's just collisions. You can edit those collisions to make it not do that, but we're just going to keep that in for right now. Okay. So yeah, this is basically just a very simple way that you can do some characters, kind of like moving around, and you can kind of have some fun with it too. So that was how you can make a character very, very quickly. Okay, so the next thing that we're going to be doing is we're going to be doing the collectible script. Now the collectibles are basically like the coins that you can collect to kind of get like a high score counter and that kind of stuff. I'm going to be showing you how you can kind of create collectibles and make them like be able to be collected, and also how to make a UI display them. The UI I'm going to do relatively quickly, and the code I'm also going to do relatively quickly, so I won't be as in depth with the player. Just because I felt like the player was a little bit more important to go in depth on, so you actually could understand what I was doing with that. But with the collectible, we're just going to be making this very, very simply and very, very easy. So what we're going to do is we're actually going to go ahead and use this mask PNG. So I'm going to take this PNG, I'm going to drag this into here, and this is going to be kind of like our collectible. So obviously with Corona going on right now, everybody is forced to wear a mask, and our character is not wearing a mask, so we're going to make him collect them. This is like a little funny, like, haha. So in order to create a collectible, the first thing we're going to do is we're going to go ahead and drag the mask into our scene. We're going to resize it to be the size that we want it to be. And once we kind of have it the size that we want it to be, we're going to basically make that the collectible object, and we're going to turn this into a prefab. So we're going to name this mask collectible. And we're going to give it a few components first of all. The first thing that we're going to give it is we're going to give it a circle collider. 2D, and this is just going to be a little circle that appears around it. Again, this is going to be when the player wants to like interact with it and collect it, so you can readjust the size of the radius of the circle here by changing the radius value. You can even change the offset value if you want to change the X and Y, if you want to make it more centered, and things like that. There we go. And we're going to go ahead and give it a script, and the script we're going to give it is we're going to call this the collectible script. Now, because we want this script, oh, oops, it popped up. Haha. So because we want this script to basically be on all of our masks, what we're going to do is once we've created our mask, we're going to go ahead and drag this down into our window down here to make a mask prefab right here. And then, oh, I didn't name it collectible. Whoops, we're going to rename that real quick. We'll open the prefab up, call it collectible. There we go. And rename the file. There we go. So now we have this mask collectible here. We'll have a bunch of masks that we can just kind of drag in to be collectibles. Now, a couple of things too. Now, in order to make this work correctly, what we have to do is we have to create a tag for this. We're going to make a new tag inside of our prefab. And this tag is going to be called collectible. The reason that we're giving this the collectibles tag is because this is going to be a collectible, and we need to make sure that it's colliding correctly. Now, the other thing we need to make sure, we have to make sure that this is the collectible and this is the tag that it has. Now, the other thing that we need to make sure that we do is we need to select our player object, our main player object, and we need to assign this one the tag of player. Now, player by default is already inside of this list. We don't have to add a tag in. We can just assign this player, but it's very important that our player has the tag of player. Now, this is where we get into tags, because tags are basically ways that we can check to make sure that items are certain items. In Unity, you don't normally check items by their names. You don't just check the player item. You don't just check the mask item. And because we have multiple masks, we don't want to have to, like, notice how when I have multiple masks in here, you have mask collectible, and then you have mask collectible parentheses 1. You want to make sure that when you use a tag, you're just using objects of that nature. So anything that has the collectible tag on it will be a collectible, whether it's a mask, whether it's a coin, whether it's a star, it does not matter. So let's go ahead and go back into our main folder, and then we'll go into the collectible script, and we'll start coding for this. Now, for the collectible script, we're going to be using just some basic code. And what we're going to do is we're going to go ahead and create. Oops, I have it running right now. There we go. Inside of our collectible script, what we're going to go ahead and do, it's not running anymore. We'll attach it and just stop running it real quick. There we go. And what we're going to go ahead and create is we're going to go ahead and create a few lines of code. Now, the lines of code that we're going to create are the following. We're using something called a public integer int, and it's going to be called coin value. This is going to be just how much points we get for collecting a mask. And actually, that's all we're going to do for right now. So we're going to actually go to the bottom, and in between void update, the bottom part, and the last bracket, we're going to add in a new function called void on trigger enter 2D. So this is what's known as a collision detection function. So this function is going to occur when something enters into the collider, and the collider is the circle collider of the collectible. What we're going to do is when this enters into the player, all we want to do is we want to add value to our score. But in order to check this first, we want to make sure that the player is touching it, and then we're just going to destroy the object. So we're not actually going to worry about score just yet. We're going to make sure, first of all, that the player can touch the object, and the object gets destroyed when the player touches it. So we're going to check, first of all, if the object that collides with it, which is going to be called other, so in our case, the player here. So if the object that's colliding with it is the player, if it has the tag of player, okay? So if it has player inside of the tag, then what's going to happen is the object will be destroyed. So we're going to just go ahead and create curly brackets here, and we're just going to do destroy game object. That's it. So again, just to recap, what this is going to do is this is going to first of all check what is actually colliding with the player, and then what is colliding with the player. Oh, I have collision up here as the default name. I'm gonna change this name of collision to other. I filled it in by default. So this is basically what object is colliding with the collider, which is the player. So if it has the tag of player, so if the object that is colliding with it has the tag of player, destroy the game object. Now, why is it important to check if it has the tag of player? Well, because it could collide with something like the ground here. If we put this inside of the ground right here, technically this is colliding with the ground. And if we play it as is, it stays in the ground, nothing happens to it, but once my player touches it, it should get destroyed. Now, if it doesn't get destroyed right off the bat, one thing that we need to make sure that we do is we need to make sure that we go into the assets for the mask collectible. So we'll go into the prefab, and we need to make sure this is trigger is checked on. By checking on this is trigger, this is going to allow us to basically interact with these objects for one-time use like that, and we should be able to go through it. Now, it doesn't look like my player is destroying the object. Now, why isn't that? Well, let's check the tag. The tag is set to player. Let's check the code. Oh, the reason it didn't go is because I didn't attach the code to Unity. Whoops. So I need to make sure that I attach the code up here every time I make a change to it, so that way it applies. So now if I were to run this, we still need to do the is trigger though. Now if I were to run this, what will happen is when they touch them, it will get destroyed, just as is. So to recap, because I went through that a little bit quickly, this is checking what object is colliding with it. If it has the tag of player, meaning if my player object, the main one, has the tag of player, then it's going to destroy the masks. And I have to make sure that inside of my masks I have set is trigger on. It has the tag collectible on, and also it has a coin value here which you can change, but we'll go to do that later. And that should be good enough. Once you kind of have that in there, you could go ahead and hit play, and then once you touch it, they get destroyed. Now, how do we actually make it so that we have a score counter? Well, in order to do this, we need to add in something called a level manager. Now, a level manager is just code that's essentially going to run alongside the game. It's going to check to make sure that the level is running as it should be running. In order to add in a level manager, we're going to go ahead and create an empty object, and we're going to call this the level manager. And all this object is going to contain is a script, literally called level manager. I'll call it level manager script just for some clarification there. So once you go ahead and create that script, you create a level manager, you go ahead and put the script inside of there, you can double click on the level manager script, and we can go ahead and edit that. Now again, I'm just going to be going through this pretty quickly, and here's what we're going to go ahead and do. So at the start, we're going to add in, whoops, I'm running code. There we go. So at the start, what I'm going to go ahead and do, I hate when it does that. It's an annoying bug with Unity. So what we're going to go ahead and do is we're going to go ahead and add in a public character controller called player. We're going to add in a public integer called coin count, which we don't have to do coin count, we can even call it like score count, in case you don't want it to be equal to 1. We can do public text called score counter. Not public text alignment, just public text, just like this. We have to add in one more thing besides just that, and then we're going to do something called scene I can't type that in yet. So the reason that we're adding in just a scene here, and we're just calling it scene, just like this. Oh, man, it's gonna autofill fine. So the reason that this is highlighting in red here is because this doesn't actually exist inside of Unity yet. We need to use something called called libraries or workspaces. They're usually called libraries, though, code libraries. Code libraries are libraries that exist inside of Visual Studio and Unity, but they aren't used by default. And the reason they're not used by default is because it makes code and scripts a lot larger. So by default, these aren't added in here, but what we're going to use is we're going to use something called using, up at the top, Unity engine .ui. And then we're going to go ahead and put a semicolon there. Now, once we do that, you're going to notice this text is no longer highlighted in red. And that's because when we use the Unity engine.ui, it's going to allow us to use UI-based functions inside of our code. So by default, we can't normally do that, but because we're using a library that has code information about this UI, we can actually do this inside of our code now. We're also going to be using one called using Unity engine, and this is going to be called something called scene management. Now we're going to be using this later, and what this is going to control is this is going to control the enemy killing our player. It's going to change up basically like when we want the game to be reset, but we're not going to be doing that just yet, so we're going to wait a minute. So now what we're going to go ahead and do is, since we have our UI actually in here, we're going to go ahead and create something inside of our void start. So inside of void start, we're going to make sure that the text is displaying. So we're going to be using our player is going to be equal, player, there we go, is equal to game object dot find game object with tag. This is finding a game object with the tag of player. So we're finding our player object first and foremost, and we're going to be getting a component from that. So once we find an object with the tag of player, we're going to be getting a component, and we're going to be getting its character controller. That's the character controller script that we have added in. And we're going to go ahead and just, whoop, right there. So we're basically just essentially accessing its character controller. Once we do that, we're going to be using our score counter .text. Now we haven't actually added in a score counter yet, so let's go ahead and do that. So in order to add in a score counter, what you're going to do is you're going to go ahead and create UI text. Now what this is going to do is it's going to create a canvas, and this is what your UI is going to look like. It's going to be large and huge, and the text is going to appear somewhere in here. Now, think of this like huge white box as just the entire screen. So the player is going to be playing along like normally on the screen here, and where this text is located, that's where it's going to be. So I'll even divide this up window into window so you can actually like kind of see the result a little more, and I'll get rid of some of the hierarchy. So notice that when I move the text around, it's going to move it around the screen of how it's going to be displayed. So what I'll do is I'll actually go ahead and position this in the top left-hand corner. And because I changed the screen like resolution for game, it's actually changing this kind of dynamically, which is kind of cool. But we'll go ahead and make it so it stays in the top left-hand corner where it's at. So what we're going to go ahead and do is we're going to go ahead and move it into the top left corner. We're only going to work inside of our scene view right here for right now. So what I'm going to do first and foremost is I'm going to go ahead and give this a new name, or at least the text inside of it I'm going to change to be score. I'm going to go ahead and change the color so it at least is seen a little bit nicer. So to contrast the blue background that we're going to have, I'm going to use some orange here. I'm just going to kind of make it like a little bit brighter. There we go. So I got score up here, and you can even change things such as the size of it. If I want to make it like 30, I'll make it 30. That seems to be a little too big, I think. Maybe I'll use 20, 25. We'll do 24. 24 looks pretty good. So score is up there visible. You can even change the font if there's already fonts that you have. By default, Arial is the only one there, so I'll just be using Arial. And then that's about all I really want to do right now. So I'm pretty happy with how that looks. So if I were to go ahead and play my game, I would have a score counter at the top up there. Now it isn't really flush as to how I want it to be flushed, so I'll flush it up against there, and maybe I'll just change the size of it a little bit more, make it bigger. You don't really want to use the scale tool on it, but you could use the scale tool on it to make it bigger that way too. It kind of makes it a little bit more blurry with the current font that I have, but I'm kind of okay with that. We'll scale it down a little bit. There we go. Make it a little bit cleaner. Awesome. So I've got the score counter in the top corner, which is exactly what I want. So now what I want to do here is I want to make sure that it stays anchored to the top here. And there's different anchors right here that you can use that will kind of like stretch dynamically with the screen change. I'm just going to anchor it to the top left up here. And what this will do is this will make it so that when I change the size of my screen, so like this here, it will constantly stay anchored to that top left and it won't change size at all, which is kind of nice. So I'm going to do that. Great. So now that I've got a score up here, I need to do a few more things. So this text, what I'm going to call this is I'm just going to call this one score text. And then what I'm actually going to do is I'm going to create another piece of text. I'm going to create UI text. And this is what I'm going to call the counter. Now, the counter is actually just going to remain blank. And all I'm going to do is I'm going to position this counter right over to the side here. I'm going to give it a size of 24 like I did before. I'm going to scale it up a little bit. But for right now, we don't actually have anything inside of here. Now, what we could do for this counter is we could go ahead and give it the text of 0, just because like as a starting score, you don't really normally have anything. So we'll give it 0 just to see what we're doing. We'll give it the color of orange that we have. It's not the same color of orange. We'll just pick her. There we go. So it's the same color. And we'll size it up a little bit more. And we're just going to give it a score of 0. Now, we're going to make this dynamically change based off of what the score actually is. So it's very important that we know what the name of this is, which is counter. And we're also going to pin this to the top left corner like I did before, so that way when the game stretches, it won't stretch either. So now that we have our UI created, we have our score created, what we're going to do now is we're going to go back into our code. Now, what we're going to do now is we're going to actually type out score counter.text is equal to, hold on one sec, there we go. So what we got to do now is we're going to do score counter.text is going to be equal to, and we're going to do a number right here plus, or we're going to do a space right here plus coin count. So we're going to keep this completely blank like this, and this is basically just saying like we want there to be text inside of here. And we're going to be using this coin count variable, which we should have, oh, I'm sorry, not the coin count, score count. I changed the name of it. Score count. There we go. So we're going to be using the score count variable. Now what we want to do is we want to make sure that it's displaying it correctly. So what we have to do is we actually have to go back into our collectible script. And inside of our collectible script, we need to make sure that the player is getting something when they are collecting the coins. So we want them to get a value. Now the value that we're going to use is we're going to be using an arbitrary value of just 1, 2, 3, 4 for score right now, and we can change it to like the hundreds later on. So in order to start to add things to it, we need to create, and this is inside the level manager script before we actually go back into that collectible script. Sorry, I got a little confused there. Inside of here, we're going to create its own variable. And the reason that we're creating a variable in here to handle score is because we want score to stay inside of the level manager, okay? We want, when the player collects something, we want it to trigger something inside of the level manager. We don't want it to trigger inside of that script, because when the object gets destroyed, you can have some like Stack Overflow issues. So we're going to be using a public void, and we're going to make a function called add coins, which is going to, or I'm sorry, add score, which is going to work with an integer, and it's just going to be score for right now. Keep it simple. Great. So now that I have this thing called add score, all it's going to be doing is it's going to be taking the score count, and it's going to be plus or equal to the score that we've just acquired. So this arbitrary value is going to be subject to change, or the score, and I keep saying that because it's true, it doesn't have a value yet. We're going to be defining what the score is inside of our collectible script. So we're just basically adding the score count to equal the score. Then what we're going to go ahead and do is we're going to make sure that the score counter dot text updates accordingly, and it updates to equal whatever it currently is plus the score count. Great. So I think that's about it. That's all we need, correct? Yeah, that's about all we need. So now that we've got that, we can actually go back into our collectible script, and now this is going to make a little bit more sense with the collectible. So now what we're going to go ahead and do is we're going to go ahead and go into our thing right here. And what we're going to do is we're going to do game level manager. And now that we have a game level manager, actually we need to define our game level manager first. So now that we have our script for the game level manager, we're going to use a private level manager. And we're going to get the game level manager. We're going to use the level manager script right there. Perfect. So now that we have that, we're just going to be using that. And then for this one, we're going to be using our level manager script right here. Dot. And then we have that new thing that we made called add score. And I think we have to actually, in order to make that apply, we actually have to attach it to Unity. We'll attach it with some errors. Our code has some errors in it. Yep. So now that we've attached it to Unity and we stop running it, I believe we can actually access it now. So add score. Yep, we can. And then after that, we're going to be adding in a value. So that value is what we have up here, so just coin value. Great. So I know that was a little bit confusing. I'm going to go over that one more time. So the reason that we added in the score here is we added in the score here because we want the score to be calculated inside of Unity, inside of the level manager, okay? Because this is getting destroyed, we don't want this to take too long to process before the destroy goes off, so we keep this inside of the level manager so the level manager can handle the addition of it. So we basically just called it here to make it add the score to it, then adding the score and updating the UI all takes place here, so that way this gets destroyed correctly. This is going to add score based off of the coin value. So inside of our masks, so if I go into the assets and I go into the mask collectible, based off of this value here, that's my notepad. That is what is going to be added to this UI. So the UI inside of add score is going to take the score count, which is essentially this coin value here. So if we go ahead and attach this to Unity, there should be no errors. If we go ahead and take a look at our game, that's my demo. Whoops. So we go ahead and take a look at our game real quick, and we go ahead and give this a value of 100. Okay. Okay. So one thing that I forgot to add into the code that I was talking about before, that I just kind of like re-looked over it and make sure it was good, was I forgot this little line of code up here instead of void start called level manager is equal to find object of game type and the level manager script. So the reason is because declaring that you're using a variable of a copy of this script isn't enough. You actually have to find the object inside of the game in order for this to work. So this code is correct as is. It should run, but you need to add in this line of code into the void start here just for collectibles. All this variable is doing is it is basically acquiring a copy of the script, assigning it the name of level manager. We're making sure that it actually exists inside of the game, and then we can actually run the function of add score, which is located inside of the level manager script. Now again, make sure that you go through your player, make sure that all of your player stuff is filled out, make sure that your level manager stuff is filled out as well. By default, the score count is set to 0, which is totally fine because that's what it actually is up here. Make sure that the score counter is set to the counter one, which is going to be the one that has the 0 in it. Let me just scroll to the top here. I don't like how much it's zoomed out, but it's fine. Make sure that it's set to the counter one, which is the 0, not the actual score text itself. Make sure that the player is set to the player, so you drag the player into here. Make sure that you set the counter to be equal to here. And then once you've got all that done, you can adjust the value of your masks by going into the prefab at any time, but by default, I set to 100. So when I collect them, you'll notice that my score increases by 100 for every mask that I collect. And again, you can go into the mask itself, into the prefab and change that. You can even have copies of masks that give different like score values. So you can make like a gold coin give like 50. You can make like a silver coin give like 100, or I'm sorry, gold coin give like 100, a silver coin give like 50, and do anything like that. And then as long as you drag in prefabs into your game like this, if I just keep dragging in prefabs over and over and over again, there's no limit to how many I can have in my game as long as I collect them. Boop. I can even jump to collect them. Boop. And 500. So that's how you can do like a score collectible right there. Pretty self-explanatory, pretty easy. Okay, so we've gotten a collectible coded in, and we've gotten a player that's able to move, but now we're actually going to go in and get into the difficult part, which is coding enemy AI. Now, there's different ways that you can do this, and this isn't like a one-way, like, fixes all kind of solution. AI is a very, very complicated field. But what I'm going to do is I'm basically going to develop help you guys develop an AI that's going to move from one place to another. It's just going to move back and forth between one location and another location, and you will actually dynamically be able to set these locations however you so choose. Um, so in order to do this, what we're going to go ahead and do is we're going to go ahead and create a square, or well, you just create like something to use as the enemy. We'll go ahead and create like the triangle, because I think triangles, or we'll do a diamond. Diamonds are scary, I guess. So this will be our enemy AI, and we'll go ahead and just drag this in, and we're going to actually give it the name of enemy. Now we're not going to go ahead and create a prefab of these, because enemies, since they're going to be subject to change, and we're going to be defining where they're going to move. We're going to just keep these as is, and we're just going to, we can create a prefab of them, but doesn't really make sense. We'll just duplicate the object and do it that way. So we have to add in a few things to the enemy. The first thing that we're going to go ahead and add in, is we're going to go ahead and add in some code for it. And we're going to add in a collider. So I'm going to go ahead and create a box collider first and foremost. It's just going to be kind of a box around the object. And I'm going to go ahead and add in a script, and this script is going to be called enemy AI. And we'll go ahead and start working on that script right away. So with the enemy AI script, we're going to go into the folder, click on enemy AI, and we're going to go ahead and get started. So with our enemy AI script, we're going to be doing a few things. We're going to be making sure, we're going to be communicating with the game level manager that we've created earlier, or the level manager script that we created earlier for the collectible script, which is kind of why this is a complicated one. And we're also going to be using another library inside of here. And the library that we're actually going to be using is we're going to be using the Unity Engine Scene Management. And this is going to allow us to manage scenes. And so basically when our enemy AI collides with our player, we want the scene to get reset so it restarts. So we're going to start off with a lot of variables. We're going to go ahead and start off with a private vector 3. We're going to call this starting position. I have just preferred to use a vector 3, but we'll go ahead and use a vector 2, since they're literally the same thing, and actually it's probably for a lot less confusion. So private vector 2. Then what we're going to go ahead and do is we're going to go ahead and do public float speed, and we're going to have this subject to change later. But by default, we're going to set it equal to 5 because we can do that, but it will be subject to change. And we're going to do a private vector 2 for our right position, and a private vector 2 for our left position. Now, why are we setting all of this up the way that we are? Well, the reason we're doing this is because we want to find out where the character is going to start and where they are currently at, and the current position is going to constantly update. And we want to have a designated left position and a designated right position that they'll go to. So think of it as like end goals of where we want the enemy to stop. Now this isn't going to chase the player. It's just going to patrol the area. So we have the areas that we're looking for, and then we need integers for them as well. So we're going to be using public ints for our desired left value, and our public int for a desired right value. And then at the end of all of this, we're going to be making sure if they're moving to the left. And we're going to be doing another one, actually, for private bool if it's moving to the right, and we're going to hit it's equal to false. So we're going to start off by setting our enemies moving to the left first, and then moving to the right later. And then we'll get into the level manager stuff later, but we'll go ahead and just start from right here. So first things first, at the beginning of when this code loads up, we want to first set the starting position. We want to get the start position. So the start position, and I realized that my cases are all off here. There we go. So the start position is going to be equal to the current position, and to get the current position, we're going to use something called transform.position. Transform.position is just like saying, hey, this thing right here, I want you to get the transform values, and I want you to take all of these and put them into the start position. So it's going to go ahead and store that into there. So the transform.position is going to store instead of start position. After that, what we're going to go ahead and do is after we store that number, we're going to go ahead and get the current position. And the current position is going to be equal to the start position at the beginning. So start only occurs when the game is first run. Whoops, I accidentally put 2 positions in there. It's only going to happen first when the game runs. So later on, the current position isn't going to be equal to the starting position, but for the beginning of our code, it is going to be equal to. So this is only going to run when it first loads up. Then what we're going to do is we're going to go ahead and set the right position equal to a new vector 2. And what it's going to be equal to is it's going to be equal to the starting position dot x plus, and now we can kind of use whatever we want. So by default, I use 10. Just as like it's going to move 10 units to the left, 10 moves to the right. But we can also change this later on. So we're only going to use a placeholder of 10 right here. But we can also change it to later on. We're going to make it to desired right and desired left. So we'll go ahead and just put desired right inside of there for now. And then we're going to go ahead and put a little like comma afterwards. I spelled position wrong, whoops. And then we're going to also define the y value that we want to move to. Now, from our AI, we're not going to be moving it in the y direction at all. So all we're going to be doing is we're going to be using the same y value that we start with. So that's start position dot y. And also, I made some typos earlier. I just changed them, just so you know. Great. So this is just going to move in a desired direction, and we're going to be defining that desired direction later. And this is just going to be a number of how far we want to move, so like 10, 20, 30, 5 units, 1 unit. And we'll change that later on. Great. So now that we've got the right position, let's go ahead and do the left position. And actually, the left position is going to be the exact same line of code, except the only thing that we're going to be changing is we're going to, instead of using the desired right position, we're going to be adding the desired left. So one thing to note too is that when you move to the left, it's always going to be negative, and when you move to the right, it's always going to be positive. So our desired position is going to be, we're actually going to be subtracting this instead of adding it. Because if we wanted to move 10 units to the left, we need to subtract it by that number. So that's why we're doing that the way that we're doing that. Great. So that will acquire the starting positions and the positions that we want it to move to. And what we could go ahead and do is we're going to go ahead and go into update to actually make this move. So when we want to move, we're actually going to go ahead and skip update for right now, and we're going to go ahead and create values to make it move to the left and to the right. So below void update, before we actually determine what direction it's moving in, we're going to create 2 private voids. And the private voids don't return anything, just for reference of what a void is. That goes into some CS stuff, and we won't cover that. But we're going to create a private void, or a function called moving right, and we're going to create a function called, or move, I want to call it moving right. And we're going to create another function down here, private void, called moving left. Now, when you first create these, what's going to happen is they're going to highlight in red, and the reason that they're going to do that is because they might not be used. So it'll get rid of them a little bit later on, but if it's highlighted, if it's underlined in red, that's okay. So what we're going to go ahead and do is we're going to go ahead and create a line of code in here called transform.position is equal to a vector 2.move towards. And what we're going to do is we're going to go ahead and move it towards its current position. So that's where it's currently at. We're going to move it towards the right because we're moving right. So right position. And then we're going to go ahead and do a comma there. And we're going to multiply that by time dot delta time times the speed. Now, what does that mean? So what this basically means is the move towards function basically takes one point in space, okay, and it finds another point, and then it's going to move that over time. So we first have to find the current position, then we need to find the desired position, or the right position that we're going towards, which we defined up here, and then it's going to translate that over time. So it's basically just moving it towards there, and it's going to constantly move it towards the right position until it reaches that right position. We're going to write the same line of code down below here. So I'm actually just going to go ahead and copy this line of code. And all I'm going to change is instead of doing the right position as I have it, I'm just going to go ahead and move it towards the left position. So I'm going to change this right to left, and it's going to run the exact same. So now we can go back up to update. So inside of update, what we're going to do is we're going to first check its current position, and we're going to set its current position to equal transform.position. So remember how update runs every single frame? Well, this is basically going to make it so that the current position is constantly updated. And then we're going to check if it is moving to the left. So if it's moving to the left, so if that's true, which we know it's going to be true at the start because we defined it as true at the start, what we're going to go ahead and do is we're going to go ahead and make sure that the function moving left is running. Okay? Now, what we're going to do down below is if move right is equal to true, then we're going to go ahead and make the function move right run. So basically, if it's moving to the left, we want to move to the left. If it's moving to the right, we want to move to the right. Now, how do we actually know if it's moving to the left or moving to the right? The way that we're going to do that is we're going to do this through two more if statements. And I actually want this to be moving right. My bad. There we go. We're going to run this through two more if statements. Now, the great part about code is because we're just doing these if statements, it's constantly going to be checking these if statements inside of void update over and over and over again. So below this, what we're going to do is we're going to check the current position. So if the current position, and we're actually only going to check the X position. So if that is less than or equal to the starting position dot X plus desired right. Now, basically, this is a line of math that I had to kind of figure out, and what it does is it checks to make sure that this basically is the current position of the block hasn't gone out of bounds of the desired right position. So basically, all it's doing is it's taking the starting position and it's adding the desired right position to it. Now, we could basically do the right position as like a shorthand way of saying this, but I kind of found some issues with that, so I found this is kind of the best method of doing this. It's basically just checking if it's moved too far to the right. If it's moved too far to the right, if it's moved past the desired point, or if it's moved to the exact desired point, we want it to start moving left. So once it's made it to that point, we want it to start to change the left. So we're going to do move left is equal to true, and move right is equal to false. And the reason that we want to do this is because we just want to make sure that once it's actually reached that position, okay, once it's gotten there, once the value's lined up, we want it to basically flip. And then we're going to run an else if statement down below, else if, and we're going to check the current position. So if that's not true, we're going to check the current position is greater than or equal to the starting position of the X value. Oops, start position dot X. We're going to make sure that that is within bounds of the desired right position, or the desired left position. And again, we're going to be using subtract here because we want the desired left to be, you know, to be that number. So if it's like 10, it's 10, and so on and so forth. Alright, so now that we've got all that written out, oh, and we need to actually put below that too, if it's you know, gotten to that bounds, we want it to start moving to the right. And then move left is equal to false. So it's a little bit confusing to understand, but essentially all we're saying is once it gets to those positions, we want to start moving in the opposite direction. So we're going to go ahead and test this out to make sure that this actually runs according to how we want to run. So inside of the enemy AI script, I have numbers here. So if we check the X value, it's going to start at 25. So if we want to move over here, this seems to be 20. This seems to kind of be 30. So for the desired left, all I'm going to do is I want to move 5 units, and for the desired right, I want to move 5 units. So if I go ahead and play that as is, and I go ahead and take a look inside of my scene, you're going to notice that this is actually just going to bounce back and forth over and over and over again. So A little bit hard to understand from a coding perspective of how that works, but basically all we're doing is we're seeing how far we want it to go, okay? So we want this to travel 5 units to the left, 5 units to the right. Now let's say I wanted to only move 3 units to the right, but 20 units to the left. When I run this code as is, it's going to move 20 units to the left, and it's going to move all the way back to its starting position, and then it's going to move 3 units to the right only. So we're basically setting boundaries of how far we want to go based off of this value here. So what you put into here is how many units or how far you'd like it to go based off of the start. So based off of the start, it's going to move 5 units and 5 units right now, and you can see that physically happen. It moves 5 units, and if we check on our thing, notice how it never goes above 30, which is 5 units off the start, and it never goes below 20. It will always stay in between those bounds. So it's a very, very easy, it's probably the simplest way to do enemy AI that I've found. Again, there's a variety of different methods that you can do AI with. This is about the easiest one that I found, is kind of finding like positions that you want it to go towards and trying to like dynamically allocate them, or like allocate them have like you as a user kind of like define where you want them to move through like using desired values that you can change. So how do we actually go about creating a script that resets our player? Well, what we're actually going to do is it's all going to go into the enemy. So the enemy is going to be the one that collides with the player, which means that they're going to be the ones that resets the player. Now, there's a couple of things that we need to make sure that we do. First of all, we need to make sure that on the box collider our is trigger is set to be checked. The reason is we're going to be using the same kind of logic for the collectibles, and so since we want the player to be able to interact with it, and we want a trigger to occur when they collide with the enemy, we want that box checked. Next, what we're going to do too is we're going to go into our assets folder and find our scenes folder. So for our scenes, yours might be named level 1. It might also be named sample scene. Since this is the scene that we're currently working in, we need to make sure that we give this a name. Now, I've already gone ahead, right-clicked on it, and renamed mine to be level 1. But go ahead and give your scene a name. Now, the big thing when naming scenes is you need to make sure that you name scenes with no spaces inside of them. You can do numbers, letters, doesn't matter how you name the scene as long as there's no spaces in it. Once we've done that, we're good to go into the script, and we'll be going into the enemy AI script. So the thing that we're going to be using is we're going to be using the Unity engine.scene management. Now, if you don't have this added in at the top here in line 4, you're going to want to go ahead and do that, because scene management is going to take care of organizing all of the scenes for us, and it's basically going to make our work a lot easier. So after you've got using scene management up, you're good to go all the way down to the bottom. And at the bottom, underneath the moving left, but before the end of our code, we're going to want to write the following line of code. We're going to be using, just like we did for the mask, avoid on trigger enter 2D. And for our collider, instead of using the word collision, we're just going to change that name to other. So basically what we're going to do now is we're going to check to see what object is actually hitting our enemy. So when our enemy collides with something, we want to check if they're the player. If they're the player, we want to reset the scene. So we're going to do if other, which is the object that's colliding with the enemy, dot tag is equivalent to the word player, and we want that with a capital P because our player has a capital P in it. Coding is very case sensitive. If they have the tag player, we're going to do scene manager dot load scene, and then we need to find the name of our scene that we want to load. Now, because we've already renamed it inside of Unity to be, I believe it was level 1. Yeah, level 1. We're going to go ahead and type inside of these quotations here, level 1, just like that. And then we should be good to go. So we've got it set so that if the player, or the object that collides with the enemy, has the tag of player, which if we check out our player object, it has the tag of player, we're going to basically load the scene called level 1. So if we go ahead and attach this to Unity and give this a play, what should happen now is when we run our game and we run our character into the box that is the enemy, you saw that it resets. So it resets everything. It resets the score, it resets the player, everything is reset. And that is basically how you can make a game in almost a little bit over an hour. Again, it's nothing too grand, but you know, it's very, that's basically all the logic that goes into making games, is getting collectibles, moving the character around, resetting when you get hit by the enemy. Now, there are some things that you can do to kind of like repurpose some of the code, and this is kind of something that you can do in Game Jam to make this a lot easier. So because since we have access to all of this code now, you can create objects that like destroy the player like when they go like too far beneath it and stuff very, very easily. And the way that you can do that is all you need to do is just create a ground piece here. You just simply move that ground piece to be, you know, the entire to the bottom of your level. You scale it up to be the entire length of your ground here, and then all you need to do is just add in the enemy script to it, or you can create a new script. By adding in the enemy script to it, if you just go ahead and give it a speed of 0, it will no longer move and have no desired left or right, but it's still going to act like you know, like an enemy. It's going to reset the player when they hit it. So if I go ahead and turn on this is trigger and I just do all of this here and I keep that ground right where it is, if my player falls off of the map and collides with that, they're going to get reset. And you could even turn off the sprite renderer too. So if I go ahead and disable the sprite renderer, it's going to kind of be like an invisible wall, but since that collision box is still enabled, that's basically going to cause the player to reset like they've fallen off the map. See? So it's kind of completely seamless that way too. Now again, you won't be able to actually see the ground. You might want to call it something like kill layer or something. But that's basically how you can do that. Also, with how you want to repurpose the grounds, you just go into your asset, go into the ground prefab that you've created, and if you want to edit the sprite renderer at all, say like you want to use the player sprite in here, you can do that, and that's how you can replace all of your assets with a finalized ground asset too. So there's a lot of different ways. I mean, obviously you'll have to fix the size of that doesn't really line up with the collision box at all. But that's basically how you can like mess with those settings and kind of like use prefabs as a way to just kind of start the whole game development process before art is even close to being created. And I think that learning how to do stuff like this and using the tools inside of Unity is a lot more practical because sometimes not all of us are great artists. You know, it took me a long time to kind of figure out how to do 2D art and especially 3D art, you know. So when I first started like making games, I kind of took every shortcut that I could in order to make the game, you know, function correctly, and then I let somebody else deal with the art. So I really wanted to kind of use this tutorial as a way to show you how to use Unity, how to just get things kind of started very, very simply, and also just kind of how to think about making games at a starting point, at a beginning level. Um, you know, definitely a game that looks nice is can be a lot of fun to play, but if the mechanics don't work and the gameplay isn't there, then it's not going to be that fun. So just kind of being able to get started somewhere like this is super, super important, and then you can have the artist on your team, you know, kind of help out with that. So this was how to create a 2D game in Unity in about a little bit less than 2 hours, and I kind of went through everything that I could go through. I will make sure that again all of the code is accessible if you need it, but you can always kind of like stop the video, go back over the code, get that copy down, and kind of like play with it and mess with it too. Don't be afraid to like mess with the code before like a game jam too, because you can kind of get some like cool things happen. And again, like it's not perfect. There are some bugs in here, but just kind of for like a purely like functional level, this is good enough. So I hope you guys enjoyed. If you have any like feedback, please feel free to like, you know, give us any feedback on this. If you found like some parts were hard to understand, if you found some parts like really helped you out, we'd love to hear all the feedback. And I hope that this is useful, or can be a good starting point for you guys going into Game Jam. Good luck to everybody who's going to be participating. So, yeah.